In this video, we're going to be talking about contingency tables and conditional probabilities. But first, what are contingency tables? Contingency tables, also known as two-way tables, are used to describe a data that was broken down by two separate variables. So for example, here we have all students in the class that are divided into categorized rather by male, whether they're male or female, and are they driving a red car or not. So we have two variables going on, and so each row represents one variable and each column represents the second variable. We also have marginal totals. So for example, for all males, we're going to have a total of 40. That describes the total, how many males we have in the class. And for females, we have 5 and 25, which is 30. And then for how many students drive red cars, we also have totals 15 that do and 55 that don't. And the value here in this cell is called a grand total. So it's gonna, if we add up 40 and 30, we get 70. And that's how many total students are represented in this table. Now, if you add the column totals, you still have to, you're going to get the same grand total. Now, don't double it up. So the column totals should be equal to the row totals, and that's your grand total. Now, we talked in the previous video, we talked about how relative frequency actually represents a probability. So we have to turn our frequency table into a relative frequency table by dividing each value by the grand total of 70. And that is what we're going to get. Before we go on to find probabilities using this table, I want to mention that we have 4 special events defined by this table. So we're going to have event 1 is an event where a randomly selected student will be a male. Event Y2 is that a randomly selected student is a female. And then we're going to have, let's say, R1 event that a randomly selected student drives a red car, and event R2 is that they don't drive a red car. Okay, the probability of event Y1 that a randomly selected student is a male is the grand total or marginal total for that row, and that's going to be 0.571. And the probability that a randomly selected student does not drive a red car is going to be a marginal total for that column, which is 0.786. My cat stopped by to say hello again. So now that we know how contingency tables work, we can start finding probabilities, using it to find probabilities. So the first question here is, what is the probability that a randomly selected student drives a red car? So that would be this event R1. So the probability for event R1 is the marginal total for the column, which is 0.214. And the next question is, what is the probability that a randomly selected student is driving a red car given it is a female? So now we're getting into the conditional probability field. So when we have the information given prior to finding, when we're trying to find a probability, that's a conditional probability that we already know something about that event, the kind of like surrounding information or prior information. So we know that the person is female. And what that means is that we only look at females now. The males do not enter into our consideration. So that means that to answer the question, our total is going to be just this total, the 30 females that we have, which have, and the probability of selecting a female is 0.429. So first of all, let's talk about the notation. We're gonna notate the event of randomly selecting a student who drives a red car. That would be our R1, event R1, given where it's usually denoted by a like a slanted bar like that, or sometimes it's a vertical line. Given that the student is a female, which is Y2. Okay, so and what we're gonna do, I'm gonna start, it's gonna be a fraction. So we're gonna basically in the denominator, we're gonna put the probability of selecting a female. And in the numerator, we're gonna put the probability of selecting a female and the person who's driving a red car. So we're gonna get that probability of a female who drives a red car is right there. And that is 0.071 and divided by the probability of selecting a female, which is 0.429. So this is how we would calculate that probability. Let's put it in the calculator, which will give me a probability of 0.1655. Now we could have, I want to explain the numbers that I have on top right here. And these are the numbers using the counts that I had before in the previous table. So in the numerator, I got the 5 females who are driving red cars. Again, I'm not looking at males at all because I know the person who was selected was a female. So out of all females, how many drive red cars? So there's 30 females altogether, and 5 of them drive red cars. So my probability would be 5 over 30, which will give me 0.166 repeated. Now, when I use the relative frequency distribution, I got 0.1655, which is close, but not exactly the same value. And I think the reason why it's not the same, it's a little bit off, is because these probabilities were rounded already. So basically, yeah, you have, if you have counts, you can use counts, or if you have relative frequency distribution, you can use relative frequencies, which are also probabilities. And here's a rule for a formula for finding the conditional probability of an event A, given that event B already occurred. Again, the notation is A and a vertical line, which we read as given B. And to calculate the probability, you're gonna take probability of A and B, basically the intersection of the two events, and divide by the probability of B. So this is the formula that you can use. So let's practice one more example for finding conditional probabilities. Says use the data in the table which summarizes blood groups and RH types for 100 typical people. These values may vary in different regions according to the ethnicity of the population. So again, we have two variables. We have the blood group OAB and AB, and we have the type of RH positive and RH negative. So two-way or bivariate data, which is summarized in the contingency table. If one person is randomly selected, find the probability that the person has group B given they have the type RH. Okay, so again, let's make our special events Y1, label them, and Y2, Y1 being RH positive, Y2 being RH negative, and then we're gonna have R1 event where a randomly selected person has a blood type O, R2 would be blood type A, R3 would be blood type B, and R4 will be blood type AB. Okay, so so we're looking for the probability that the person has a group B, which is R3, given they have the positive RH, which is Y1. So that's what we're looking for. And again, we can either use counts or we can use relative frequencies. And either way, I need my marginal totals in order to be able to answer those questions. Now, I think it would be too much to convert all of these into relative frequencies. So I'm just gonna stick with marginal totals for this problem. And my marginal totals are 86 for positive RH, 14 for negative RH, and for the blood groups of 45, 40, 10, and 5. And my ground total is 100, which actually fits my marginal totals, and this is what I was also given in the problem. So let's use those numbers. For the numerator, I'm gonna put the event, the counts for event R3 and so R3 and Y1. Okay, and that would be R3 and Y1 is 8 right here. So that's 8. And for the bottom, I'm going to put the total for event Y1, and that total is 86. So my probabilities would be 8. My probability would be 8 divided by 86, which is 0.093. And I would get the same result if I used relative frequencies here as well. Just make, if you have extra time, check it out, convert these into relative frequencies, and let me know. Now, with calculating conditional probabilities like that, it's okay to use the marginal totals. But if we're talking about calculating just a regular frequency distribution, the convenience of converting to relative frequencies, because relative frequencies are probabilities already. if you're just using frequencies with those, you still have to convert them into probabilities before you can use them in the formulas. Just keep that in mind. Now, it works out with a conditional probability from the from the contingency table.